So the first is to write down the normal distribution definition. A scientist found that the time taken m minutes, so I wrote x, so remember we have to follow the question. So the random variable should not be x here, the random variable should be m here. So m minutes, so the random variable is m, normally distributed to carry out an experiment, can be modeled by a normal random variable with mean 155 minutes. So the mean is 155 minutes, and the standard deviation, remember the sigma standard deviation is 3.5, but we have to put here sigma squared. This would be 3.5 whole squared. Sometimes they give standard deviation in the question, sometimes they give variance directly. In that case we can write that, but here it has to be sigma squared. So here the probability is given and we have to find the random variable. But before we do this, let's first do the z-score, because either way you have to do the z-score first of all. So z is less than or equals to m minus 155 is the value of mean, divided by the standard deviation is 3.5 equals to 0.30, and 0.3 is the same thing, doesn't really matter. When you have z is less than, the best thing to do is draw a picture of the standard normal distribution. Remember this is 0. So you know less than, z is less than and the area is 0.3. Less than means the left hand side of the diagram, and you know the total area is 1. Half of the area is 0.3. So if less than, if it is on the less than side and on the left side and it is 0.3, so it should be like this. This region should be 0.3. This region should be 0.3. And this is definitely negative. Less than 0 is negative because it's the standard normal distribution. So instead of this thing, let me write, therefore probability of z is less than minus a equals to 0.3. So you know when it is less than and it is negative, you can just reverse the symbol. Greater than a equals to point a. Then if you have greater than, you can write 1 minus probability of z is less than a equals to 0.3. Remember, in continuous equal to sign, whether you give it or not makes no difference. So we can write it as 1 minus 0.3 equals to probability of z is less than a. And let me continue here. So we can write probability of z is less than a equals to 0.7. Now let's look up the table. This table is not going to work for us, so we are going to move on to the previous table, the main table. So here let's take a look at the probability. We need a probability of 0.7. So let's look for a probability of 0.7. 0.5. Let's look in the probability column. There is nothing here. Let's go up. 0.7. Now we have two choices. We can either take 0.6985 or we can take 0.7019. Either one will do, but it's preferable to take the closest one. If you take 0.7019, it is 19 more than 0.7. Actually 0.0019 more. If you take this one, it is only 15 less than 0.7. So this is closest, 15. So the value of z for this probability is 0.52. So I can write, therefore probability of z is less than 0.52 is equals to 0.6985. Now that we know the value of a, we can just write this equals to minus a. After all, it was this. Instead of this, I wrote minus a. So I can write, therefore m minus 155 divided by 3.5 equals to minus a. A is 0.52. A is 0.52. Remember, the substitution was for minus a. So let's do the calculation. I can write m minus 155 equals to minus 0.52 into 3.5. Therefore m equals to 155 minus 0.52 into 3.5. Now let's do the calculation here. So the calculation would be 155 minus 0.52 multiplied by 3.5. So that would be 153.18. 153.18. That is the value of m.